Hi, in this session we will learn about how to define an angle in a plane in terms of radians and how to convert radians to degrees and degrees to radians. Now let us consider the circle that's drawn here and the two-dimensional coordinate system that's shown by these two axes x and y, and let us say that point O is the origin of the coordinate system, which is also the center of this circle, and then there are 2 points P and A on the periphery of the circle, and point A in fact is the intersection of the circle with the positive x-axis. Okay, so now imagine that the line segment OP, which whose length is nothing but radius r. So let me write that down here. Line segment OP rotates in this plane around point O, let us say in the counterclockwise direction, and it rotates by one full circle. So let us say that it rotates by one full round, and it comes back to its original position. And in doing so, what is the length traveled by point P? So point P travels along this path shown here, and the length of that path we know is the circumference of the circle, which is 2 pi r. So let me write that down here. 2 pi r is the length traveled by point P. And what is the angle that is swept by the line segment OP in this process while it covers one full round? That angle is defined as 2 pi radians. So let me write that down here, that while point P travels a circumference of 2 pi r, the angle swept by the line segment OP is 2 pi radians. So therefore 2 pi radians is nothing but the angle subtended by the an arc of a circle on the center, whose length is the full circumference of the circle. Right? That's the definition of 2 pi radians, and that we know is equal to 360 degrees. Therefore, we can define an angle of 2 pi radians as the ratio of the circumference, that is 2 pi r, to the radius r. Now note here that this circumference 2 pi r is nothing but the length of the circular arc that subtends this angle 2 pi at the center, right? So therefore now we can define any angle theta in terms of radians as the length of the arc, the circular arc length that subtends that angle theta, divided by the radius of that circular arc, right? So let us say that this angle that the line segment OP makes with the positive direction of the x-axis is theta in the counterclockwise direction, and the length of this arc AP out here is L, and therefore angle theta could be defined as length of the arc AP, which is L, divided by the radius of the circular arc, which is R.